Hey folks, on my previous videos we talked about the difference between the databases and ontology, and I was mainly talking about the relational databases and how we work with the data in the relational databases setup, what the difference between this closed world and open world approaches, and how to stay open to the new knowledge and all other things. And all of them are still valid. And but what about the graph databases and the graph databases and ontology? Because that's also quite interesting dimension, right? So first of all, you need to understand what kind of graph databases and graph storages we are talking about, because we could have the classical RDF store and maybe with some binary capabilities, or we could have, for example, full-scale property graphs with the cipher queries and all of the things, and there we have the open cipher on and all amazing tools. But still, I struggle a lot for recent months because I try to build the ontologies for the property graphs, and every time when I go and try to find the tools that work with the ontologies for the property graphs, I found nothing. So the best that I found actually, that if you use the Neo4j, you could have these semantic tools that actually allows you to operate with the OL and store even the OL inside the graph database. They store actually the OL as a graphs, so your ontology is the graph also, but unfortunately you have quite basic reasoning capabilities. So when we're talking about the property graphs, we always have the challenge that if you want to work with the ontologies for the property graphs, you need to translate the property graph to the RDF, and then we have all the tools that allow us to work with it, and it's quite sad because it's challenging, because we not always could do this translation on fly. But the biggest mind opening to me happens when I just realized that the ontologies, they not about the OVL because it's just a serialization format. They more about the ability to reason. So it's a reasoning frameworks, and a lot of ontologies could be built in a common logic because they just set the rules and relations between the entities. And it's a main difference between the graph databases and ontologies, because ontologies give you the tools and possibilities to reason on top of the graph, and graph databases more, in a case of Neo4j and graph-oriented databases, they more oriented on the structured queries, quite effective queries, multi-hoop queries, and so on. So they don't give you the possibility really to reason. And ontology have two superpowers. So the first superpower of ontology, it's making the data interoperable and understandable to others, and have ability to share this understanding with others. And another quite big superpower of ontology, it's a possibility to reason. So you have the subclasses, hierarchies, thesauruses, and all these relations and links, and you have the links between the entities that actually not just the edges in a graph. They have much complex relations that could be expressed with ontologies, but could not be maybe so effectively stored in a graph. And that's a main power, and the main difference between the ontology and graph databases, it's the super ability to reason on top. And are we able to teach the LLM to do the reasoning on base of ontologies, it's yet another big question, because the ontology and the graphs, it's all about the knowledge representation. So how to make this knowledge representation accessible to the LLMs and use the LLMs as reasoning engines, it's completely separate topic of research and discovery. And I'm super keen to work with somebody on this, because we desperately need such tools. So stay connected. If you have some ideas around these topics, just let me know. I will be happy to work with you. Cheers.